Okay, I think we should get going. We should have everyone joining us now. Hello, everyone. Welcome and thank you for joining us. My name is Dale Kazuki. I'm Senior Campaign Manager here at Arm. And we'd like to thank you for joining us today. We'll be demonstrating how the latest version of Total Compute Solutions can offer next generation experiences in a range of device markets like laptops, phones, and XR. And in order to do that, I need to introduce my colleague, Senior Director of Solution Management, Kinjal Dave. Kinjal, welcome.
Hi, Dale. Thank you. I hope you can hear me okay.
Loud and clear, coming through loud and
Oh,
clear. Thanks for joining us today. So, Kinjal, welcome to our audience here. Please feel free to fill in questions in the sidebar as we go along. Keep them coming. And I'll be back to facilitate those questions later on. But for now, it's over to Kinjal.
thanks, Dale. So, hey, hello everyone, and thanks for joining. And today I'm excited to be here to talk to you about our second generation of total compute solutions that we just announced recently, and really just touch upon what do these mean for the mobile experiences for the future devices. Now, at ARM, from almost last 3 decades, we have collaborated with a huge ecosystem of partners to shape the evolution of mobile compute and really push the boundaries of what is possible. And we are continuing this collaboration in a new decade with new challenges. And based on this deep collaboration across the industry, we have outlined three fundamental drivers for the next decade of client devices. The first one, obviously, is performance. Now, performance demands are skyrocketing across all the client market segments, but the constraints on cost and power, they are not going away. So if we look at the premium mobile devices, they continue to demand increasing performance in double digits year on year to really push the boundaries of what is possible. But the constraints on the thermals are becoming challenging generation on generation. Similarly, emerging use cases like 8K video, they demand a lot higher performance in the digital TVs. But then there is a constraint on the silicon cost. And then if you look at smaller form factor devices like wearables, right, there is a lot more increased integration of sensors in these devices, which demands higher performance too. But then there are strict constraints on power for maximizing battery life. So yeah, performance needs much higher across all price points and all device categories. The second driver is security. So, robust platform security is clearly becoming the norm. But then there are massive hurdles on the cost, the performance, and the fragmentation across the ecosystem. And then finally, it's the developers. The developers require the ease of debugging, deploying, and optimizing their apps across a broad range of client devices. So, what are we doing about it? So, these three market drivers, compute performance, security, and developer access, they are the pillars of our total compute strategy. Now, what does this strategy mean for the solution that we deliver? So this strategy translates into three distinct drivers for ARM's total compute solutions. The first aspect is to really improve the performance for complex real world use cases in addition to the traditional benchmarks. So we follow an approach of cross IP, system wide optimization to improve the overall system performance for demanding use cases like gaming and AI camera, about which I'm going to touch later. Second, we continue to look at ways of enhancing the platform security with each generation of compute solutions in a very broad partnership with the ecosystem. And finally, as we relentlessly pursue the performance improvements year on year, we also need to ensure that this performance is accessible to developers who can then deliver rich, immersive experiences on mobile devices. So, going on from the strategy to looking at the scale of challenge that we have in architecting use case driven solutions. So there are about 3 million apps that run on billions of client devices that are built on ARM platforms. And these applications consistently push the limits of what is possible using your smartphone or any other mobile device. Now, whether you want to translate languages in an instant or use your camera to search the web automatically, or automatically caption media playing on your phone, or my favorite is using maps to drive in London, there is just an ever increasing amount of choices of apps. Now, from a compute platform perspective, these millions of applications represent a huge challenge for each generation of a client device. So, the question for us is really how do we continue to deliver this relentless innovation that enriches the experiences for the end users of the next billion smartphones? So, how do we map the challenge of improving user experience for these millions of apps to compute requirements for ARM's next gen platform requirements? So, our approach is threefold. First, understand the workload characteristics across a broad category of new and emerging applications and look at it from a system level. Second, we analyze the compute bottlenecks to improving the user experience on key apps like gaming or AI video. And then finally, a close collaboration with our silicon and ecosystem partners to co create solutions that will deliver rich and stunning experiences in the future devices. So, based on our extensive study of several smartphone applications, we have observed a widespread in terms of performance requirements under different power constraints, which is represented in this graph over here. Now, if we look at the low end of this graph, you have workloads that mostly continue in background and have very low power requirements. And if we look at the mid region, we then have the use cases like gaming and video, which are computationally intensive and they need to deliver sustained performance. And then towards the far right, we have bursty use cases such as app launch or web browsing. And then, of course, towards the top end, the sort of red orange region, are benchmarks. Now, it is important to note that the benchmarks usually target a specific IP and not the entire system. And in our profiling, we have found that improvement in an IP specific performance benchmark does not really translate into improved experience for real world use cases. So now if we look at the characteristics of these workloads, so the
Kendra,
background tasks.
can I, sorry to interrupt, just getting a couple of questions in about screen share. Some people can see, some people can't see. And I just wanted to, just to be double sure, we end screen share quickly and then reshare, just to make sure everyone's seeing the same thing.
Okay.
Thank you. Sorry to interrupt.
How is the screen
Okay.
share?
Thank you. Thanks for that. Sorry to interrupt.
Okay, no, thanks. Right, so we were looking at the characteristics of these workloads. So now if we look at the background tasks that need to execute in extremely low power budget and they try to maximize the battery life. Then we have the compute intensive workloads that need to deliver maximum SoC performance within a given budget, like gaming, which is shown over here. And then finally, the bursty workloads that work only for a very few seconds, but are very critical for responsiveness. So what are the areas that we have tried to focus in our second generation of total compute solutions that we announced recently, which we kind of use the acronym TCS22? So we focused on four areas. The first one is to look at delivering immersive gaming experiences, the continued improvement of immersive gaming experiences on ARM platform. Second, we have focused on expanding the accessibility of machine learning capabilities to enable rich visual experiences on future mobile devices. We have also focused on building up on the security features that we introduced last year and enhance the security capabilities of the ARM platform. And finally, as ARM v9 based solutions scale into mainstream devices, TCS22 provides more scalability to enable trickling down of premium capabilities for a broad category of client devices. So we'll be going into the details of some of this in the slides to come. So let's start with gaming. Now, gaming continues to be a very important use case for mobile devices. And if you look at some statistics, there are about 350,000 gaming apps and about 2.2 billion active mobile gaming users per month. And out of this, around 80% of gamers consume gaming content on Android platforms. Now, in the first generation of Troll Compute solutions that we announced last year, and on that basis, devices are shipping this year, we focus primarily on improving the performance of gaming workloads as well as efficiency. And we did that by introducing a new ARM v9 CPU cluster, which delivered performance improvements, new GPUs, as well as the system IP solutions to deliver all these gaming performance improvements. So the second generation of the Troll Compute solutions have a focus on improving sustained gaming experience by optimizations in different areas. Now, why sustained gaming? So sustained gaming is really a key on mobile devices because as soon as the device hits thermal limit when playing games, frames start dropping and this results in a subpar gaming experience. So we really looked at what we can do to improve efficiency across the system when gaming workloads are being run. Of course, this is in addition to the usual performance optimizations that we would do on the different IPs. So now if we look at some of the specifics in what we did in the second generation Troll Compute solution, we first look at the CPU cluster and tuned it to deliver sustained gaming. So the whole CPU cluster, including the Cortex-X, the Cortex-A715, and Cortex-A510, work together to deliver best-in-class performance and efficiency for gaming workloads running on it, along with the GPU. Next, in addition to the Mali G715, we are introducing a new flagship GPU, Immortalis. This provides higher core counts and introduces hardware-based ray tracing, primarily designed for mobile. We have also worked on improving the system cache utilization by the new GPUs. More cache hits by the GPU in the system level cache means better overall system efficiency. And better system efficiency means you can sustain AAA gaming experience even longer. And finally, it's not just about hardware. So the TCS 2022 also includes GPU driver optimizations as well as compiler optimizations on the CPU, which then effectively translates into improved gaming experiences in the end devices. So what do all these features mean when they come together in a system context? So let me tell you a little bit more about how we have architected the TCS22 solutions to enable immersive gaming experiences and what are some of the benefits that we have measured on an internal reference platform. So here is a simplified diagram of a TCS22 example reference system that we built to measure the improvements for a whole range of use cases and benchmarks. Now, in this case, we obviously run a whole bunch of AAA games. Now, this system includes a typical 8-core CPU cluster that you would expect in a premium device. So, in this system, we used one Cortex-X3 core, 3 Cortex-A715 CPU cores, 4 Cortex-A510 cores, all of them sharing an 8 megabytes of level 3 cache into the DSU. The compute cluster and the Immortalis graphics cluster, they are connected to the main memory through ARM's NI700 interconnect, which has a 16 megabytes of a system level cache. Now, of course, this is a simplified diagram. We do model other agents in the system, but that's kind of omitted here for the sake of simplicity. Now, what we do is we build this platform and we run it on an FPGA, and we then execute different gaming workloads on this platform running an Android S, the latest software stack that's available. Now, the key thing is that gaming is a system workload. So it is important to measure system-related metrics rather than just looking at what is CPU performance or GPU performance. So we looked at measuring some of the system metrics, and here is what we measured. So the first metric we looked at was the impact on the memory bandwidth or the DRAM bandwidth. On TCS22, we observed up to 23% DRAM bandwidth reduction, depending, of course, on the cache size and the gaming workload. So this improves efficiency and ultimately delivering more sustained gaming performance. Next, we measured about 16% reduction in system power for TCS22 versus our previous generation total compute platform, the TCS21. Now, this improvement is significant and will also deliver more sustained gaming performance to the millions of mobile gamers. And finally, we have also measured up to 28% performance improvement across different gaming workloads. So all in all, this whole strategy of looking at cross-IP system-wide hardware software optimization leads to meaningful improvements in a real-world use case like gaming. Now let's look at ML and AI. So AI is becoming very pervasive across all mobile devices. What this means is ML workloads are literally redefining every traditional mobile use case while unlocking new use cases based on the AI-powered services. So if we quickly look at the key categories of ML workloads that we see driving the ML compute requirements for the future mobile devices. So on the lower end of the ML performance spectrum, we have compute requirements that are related to gathering data from more and more integrated sensors to provide the context information. Now, these workloads, they have extremely small power budgets. Next is the interesting one, voice-based services. So according to a research, around 97% of mobile users are using AI-powered voice assistants today. And yet another research predicts that around 8.4 billion digital voice assistants will be in existence by 2024. That's barely 2 years from now. And what is more interesting is that there are going to be more voice assistants than the number of humans on the planet. What does this mean? This means a relentless pursuit of delivering intuitive interactions through voice on mobile devices. In terms of computation, this needs a whole class of NLP algorithms to run extremely efficiently on mobile platforms. And then finally, on the top right of the ML performance curve, you see the smart AI camera use cases. So you can think of the AI camera as a superset of all the three categories of use cases that I've shown here. So just like the gaming use cases we discussed earlier, the smart camera uses so many diverse technologies, including computer vision, image recognition, machine learning, deep learning, speech and voice recognition technologies. So jointly, these can deliver rich and visually stunning experiences for the end consumers. Now, the key thing to note is that all of these categories of ML workloads are extremely diverse in terms of performance, power requirements, and even the data type support. So processing these workloads efficiently means a system-wide ML compute capability to deliver compelling user experiences. It's not about just having one component that can handle all these kind of workloads. So our approach is to integrate powerful AI capabilities across all of our processors and then make this easily accessible to the developers. So the first generation of total compute solutions, which we announced last year, introduced key capabilities like matrix multiplication, scalar vector extension, also known as SV2, and also support for BF16 format in the ARM v9 CPU cluster. We also introduced the Cortex M55 processor with the Helium extension support. So Helium is the M profile vector extension, which helps accelerate ML and DSP use cases on client devices that, for example, integrate a sensor hub. And here is just a snapshot of the massive performance improvements that we have been able to deliver on the ARM platform from the first generation. Now, coming to the second generation of total compute solution, we continue to expand the accessibility of ML compute on ARM platform. Firstly, we are introducing hardware accelerated matrix multiplication in the TCS 2022 GPUs, that is the Mali G715, Mali G615, and the Immortalis G715. Next, The ML performance on the TCS22 platform is even enhanced further when we factor in the optimizations from the ARM compute library, also referred to as the ACL. So these optimizations for both CPU and GPU have increased the ML performance on ARM by up to 20% in many key partner use cases. Furthermore, over the past year, we have been working very closely with Google to enable broader access of ML performance for ARM platforms. And very soon in Android 13, our ML software libraries, that is ARM-NN and the ACL, will be accessible to all Android third-party developers. These will be regularly updated via Google Play services. So it just ensures that the end users and the developers always get the latest and the best ML performance on ARM. And finally, we are also introducing ARM's highest performance Cortex-M processor, the Cortex-M85. This supports Helium extension, and we anticipate this to enable new and exciting use cases for ML and DSP workloads in client devices that have a constrained power budget, such as wearables. So let us look at what do all these improvements mean at a platform level. So as I mentioned in the slide before, we have taken a holistic approach for improving ML performance across the whole platform. There are micro-architectural hardware design improvements, introducing MATML to the GPU, and the usual CPU microarchitecture improvements to accelerate ML workloads. But we haven't stopped there. There are also system-level optimizations. There is optimizations related to fine-tuning the caches and looking at reducing the latency to the main memory. And of course, top that up with the software optimizations in the ARM-NN and the ARM compute library. So what we did is we measured the ML workloads versus the previous generation solutions, using the same FPGA platform running various ML workloads across the CPU and the GPU using ACL as well as the ARM-NN. And here is just a snapshot of the performance improvements that we see. These performance improvements range from about 30% for object classification to about 43% for object detection. Now, let's look at security. So security continues to be a never-ending arms race with the hackers. As the value of the personal assets on the client devices increase, so does the number of threats. And providing platform security ultimately comes down to three key areas. First is protecting the application and user data from threats. Second, protecting system resources. And third, providing app isolation as appropriate, either from the system or other applications or from the user. The first implementation of the ARM v9 architecture, we introduced 5 new security technologies to boost ARM's platform security capabilities. In TCS 2022, we continue to evolve the security capabilities of the platform. So let me tell you a little bit more about it. So first, we look at the in-process security. In that, we have added asymmetric MTE, which can be thought of as a combination of synchronous MTE and asynchronous MTE that we introduced last year. Effectively, it gives more options to the developers for developing memory bug-free applications. I'll cover this a little bit more in the next slide. We have also introduced enhanced privilege access never capability, which kind of helps securing user data against just-in-time code attacks. Next, we have looked at strengthening the security in the trusted execution environment. Now, in a typical smartphone device, in addition to the applications that run in the normal world, there are applications that we call as trusted applications that run in the trusted environments. So an example of an application running in a trusted environment would be face recognition. Now, if a trusted application is compromised, it may significantly compromise the security and privacy of the device. So what we have done is, we have made it even more robust by enabling some of the features that are already available in the normal world. So the control flow integrity exists in the normal world through PAC and BTI. We have now enabled the PAC and BTI in the trusted execution environment, and which allows protecting the software residing in these environments against ROP and job attacks. Similarly, memory integrity protection was also available in normal world through MTE. By enabling support for MTE in trusted execution environments, we make it more robust by securing these environments against memory vulnerabilities. And the reference implementations of these capabilities are available through trustedfirmware.org. The next part that we have focused on is really enabling this high-end feature sets like PAC and BTI into even smaller footprints, therefore expanding the scope and the support of these advanced features into smaller footprints and enhancing the platform security even more. Now, ARM v8m already provides security and memory protection features through TrustZone for ARM v8m, features like memory protection unit and privilege execute never. So all these existing features, they offer efficient mechanisms for isolating critical security firmware as well and private information, enforcing privilege rules, and even separating processes as well as enforcing access rules. Now, with Cortex M85, we have introduced PAC and BTI into our Cortex M processor line. Now, this is an industry first. So PAC and BTI builds on these existing features in the Cortex M and offers new tools for mitigating the ROP and JOP attacks for embedded use cases. And finally, we have looked at ways of making the secure firmware update process more robust on ARM platforms. Now, there have been diverse ways in which firmware has been managed, the firmware updates on ARM platforms. This means that there is a larger threat surface for the firmware. So we are looking at introducing standardized mechanism to deploy new firmware on device in a secure way. This allows defragmentation of the process of updating the devices and helps making it more secure. So these are just brief highlights of the key security features of the TCS 2022 platform. Now, a quick note on the memory tagging extension or MTE. So with the introduction of MTE last year, developers are finding MTE to be useful for developing memory bug-free applications. What MTE aims to do is to increase the memory safety of the code written in unsafe languages like C or C++. So the testaments that we hear from developers and ecosystem partners that they have managed to detect hundreds of bugs within a single software application instance gives ARM confidence that this is the right technology to invest and empower the developers with. Thanks to MTE, identifying hard to find memory bugs is a much easier task, allowing the code to reach production quality faster and reducing time to market. The benefit of this is with more bugs found in during development time, less updates needed to be shipped to customers, reducing the cost. Fewer bugs in the field translates directly to fewer security problems in the field and keeping customers' data and reputation secure. And with TCS 22, we have taken one step forward to provide one more option for the developers by introducing asymmetric MTE mode, which developers can use in runtime environment for accurate memory safety issue detection. So you can think of asymmetric MTE as a variant of MTE that provides more flexibility to the developers for memory bug detection. Asymmetric MTE enables better detection of memory safety issues than the async mode, but then because it is architected in a way that it is faster than the sync mode. So just at least one more option for them to look at some of the corner cases. So that kind of brings me to rounding up. What are all the new things that we are introducing in this TCS 22 solutions? So first, as a part of TCS 22, we are introducing second generation of ARM v9 compute cluster with double-digit performance, efficiency, and power improvements. We have increased scalability by up to 12 CPU cores for those use cases which need even more compute power. A lot of work has been gone on to tune the CPU cluster for really giving the best-in-class sustained gaming performance. And of course, we have also added features like asymmetric MTE and EPAN, which enhance the in-process security and improve the overall platform security as well. On the GPU side, we are introducing ARM's most performant graphics processor with new capabilities. We're introducing Immortalis G715, which again is quite scalable. It scales up to 16 GPU cores We're introducing the hardware-based ray tracing as well as variable rate shading, so that massively helps not only with the gaming performance, but also with the sustained kind of performance improvements that I mentioned earlier. And then, of course, system IP is what connects all these, compute engines together in a system, and it's very critical. So we have continued to update our system IP to provide more scalability and efficiency improvement. So, for example, we have given more configuration options for NT so that the ARM v9 solutions can scale into lower cost tiers. Similarly, we have done system cache optimizations in our SLC as a part of the CoreLink family, which allows, again, overall better improved performance as well as efficiency across a whole range of use cases, including gaming. And then, of course, with TCS22, we also provide the optimized physical IP that allows our partners to build really best-in-class physical implementations of ARM IP in advanced nodes like 5 and 4 nanometer. I also mentioned about the new Cortex M85 CPU, which is our highest performance CPU for the embedded use cases in the client, for a whole range of client devices. We have also added custom instruction support for Cortex M55, which might again be useful for different categories of the embedded client use cases. Now, of course, all of that was hardware and system. We also kind of built and validated the latest Android software stack on ARM's example reference design, which I introduced earlier. And this is kind of delivered as a fixed virtual platform, or FVP, which will be available soon on ARM developers website, so that you can start building the software applications before silicon is available. All of this also comes along with tools which are very critical. So we have a whole collection of development tools and models that accelerate hardware and software development. So we basically provide this in two buckets. One is the hardware success kit, which is primarily targeted for silicon providers. They have a whole range of tools which help them, do the system design explorations, choose the right configurations, and so on, helping them accelerate the time to market from design to the tape out. And then, of course, we also kind of deliver the software success kit for the TCS22 platform, which will allow developers to build, debug, and analyze a full stack software for the TCS22 system. So that's it. This is, like, in summary, key highlights, lots of technology, but all of this kind of really drives improvement on the kind of the visual experiences, the gaming experiences, increasing security, and of course the scalability for the future mobile devices. So to kind of summarize, the first generation of Toll Compute solutions that we announced last year, they are already enabling the innovation for a new decade. And the second generation of Toll Compute solutions that we are announcing this year, this continues to build on that momentum. So the TCS22 brings together all the elements of the ARM platform that is shown here: the tools, the software ecosystem, the physical IP, the compute IP, the standards, and the support in a foundational technology solution. And we believe that this TCS22 solution will allow our partners to build specialized compute solutions for every performance, every power, and every price point. So that is it from me. We can now take questions.
Thank you, Kinjal. We've got 3 questions in, one of which you've just covered in this slide. So that was question here: Total Compute solutions. What do you mean by solutions? How is it different from IP launches in the past? I think that we've just covered that in this very slide. So that's very pertinent. And then another question that we have, penultimate question. Oh no, we've got another one coming in here. We've got one here. Okay, how are you delivering the performance uplifts for gaming and ML?
That's a good one. So I just want to reiterate, the whole approach with the workloads, like what the gaming and ML workloads is, these are not really tied to one particular IP in the system, right? We really need to look at the whole cross IP and the whole system kind of approach. So if I look at gaming, and looking at this diagram, right, we kind of looked into the whole of our compute IP stack, what we can do in the GPU, what kind of features are needed there with the Immortalis, like hardware-based ray tracing, some of the other features like variable rate, VRS that I talked about earlier. On the CPU side, we looked at how do we optimize our cluster of the Cortex X, the Cortex A7, 15, as well as the Cortex A5X, right? How does the gaming workload run on that, along with the system IP optimizations? That then also looking at the software side of things, right? And how do you optimize the software like the DDK? So it's really a whole holistic system, hardware, software kind of approach that we take to optimize gaming as well as ML performance.
Thank you. Another question just in. Are trustable software layers for TEE on our roadmap?
I won't be able to comment on that.
Okay, all right. And the final question I have here: the 3 pillars of total compute, performance, security, developer access. Can you talk? What do you mean by developer access?
That's a very good question. So, I mean, there are 2 aspects to developer access. One is how can we, like as we are providing this new rich capabilities into a platform, how can we make it easier for developers to access all of this, right? All this performance improvements, ML performance, how can we make it easy? So that's first aspect for them to access it. And the second part is kind of building tools and capabilities into our solutions that makes it easier for developers to build their applications faster, bug-free, in a more robust way.
Okay. All right, they're all the questions. Unless just check there's no more. No, that is everything. I think we've covered everything. Kendra, unless there's anything else we need to comment upon, I think we'll wrap there, shall we?
Yes, absolutely, Dale.
All right, thanks for your time today. We appreciate it. And thanks to our audience for joining us today. Thank you for coming.
Thank you.